This is Dr. Fitzgerald. In this video, we want to discuss examples of rationalizing the denominator. So let's take a quick look at an example. Here we want to rationalize the denominator when I have the problem 5 divided by 2 square roots of 3. Here, in order to rationalize the denominator, that is, get rid of the denominator, the radical in the denominator, we simply multiply both the top and the bottom, that is, multiply the numerator and the denominator, by the square root of 3. In hopes to do that, we want to make this a perfect square. And in that way, we'll take a square root of a perfect square, and that will get rid of our radical. Now we just multiply straight across, because we're just multiplying fractions. So when I multiply straight across, we yield a value of 5 square roots of 3, because we're just multiplying directly across, over 2 times, and literally that just gives us the square root of 3 squared. However, we know that if we continue to work this problem, we have 5 square roots of 3 over 2, but the square root of 3 squared simply becomes 3. And now we just simplify the problem. So the top is simplified. We have 5 square roots of 3, but our denominator now becomes 2 times 3, which is simply 6. And that would be our final answer in this case. So let's just recap. In order to rationalize the denominator, in this example, we multiply both the top and the bottom, the numerator and the denominator, by whatever this radical is, if it's a simple radical. So we multiply both by the square root of 3, top and the bottom. Then we simply multiply it across. 5 times the square root of 3 divided by 2 times the square root of 3 times the square root of 3, which gives us 2 times the square root of 3 squared. And that problem simplifies to 5 square roots of 3 over 6. Now let's look at another example. Let's try to rationalize the denominator for 5. You don't want 5. Let's rationalize our denominator for 2 over the cubed root of 5. Now that problem's a little bit different. Now I have a cube root of 5. Now that's just a tad different from the problem before. In this particular case, I don't just want to multiply by another cube root of 5. Remember, we want to get rid of this cube root. How do I do that? I need to make this a perfect cube. In order to make it a perfect cube, I need to multiply it by 2 more. I need that to be a 5 cube at the bottom. So I need to multiply that by 5 squared. So if I multiply the bottom by that, I also need to multiply the top by the cube root of 5 squared. Once again, we're just going to now multiply across. So my top becomes 2 times the cube root of 5 squared over the cube root of 5 to the 3rd power, and that's what I needed to end up at the end, the 5 to the 3rd power, to match that index of a 3. So now we continue to simplify this problem. We have 2 cube roots of 5 squared over the cube root of 5 cubed simplifies to just 5. So there is the final answer for this problem. 2 cube roots of 5 squared, all divided by 5. One last example that we want to look at in this particular case is one last situation. And here in this particular case, we want to look at rationalizing the denominator for 2 divided by 3 plus the square root of 7. Now this problem looks a little bit different from the previous problems that we've looked at because now I have 3 plus the square root of 7. So I have a plus or a minus along with our radical. So this becomes a little bit different. The strategy that we use in this case is to multiply by the conjugate of the denominator. So what's a conjugate? The conjugate is the exact same terms with an opposite sign. So the conjugate of our denominator here would be 3 minus the square root of 7. And I have to multiply the top and the bottom by 3 minus the square root of 7 for this particular example. Now once again we have to multiply across, and let's put our parentheses there just to keep track. So we want to multiply across. So when I do that, we end up with 2 times 3 minus the square root of 7. That's our numerator, but let's look at our denominator. This kind of looks like a binomial times a binomial in this particular case. So we really want to multiply this guy out, or if you guys remember that term, that strategy or method called the FOIL method. You want to FOIL this out. So let's do that. The bottom, I have to multiply the first terms by one another. So I want to multiply 3 times 3, and you get 9. Then I want to multiply my outer terms. That's the second strategy for the FOIL method. My outer terms would be 3 times negative square roots of 7. So that becomes minus 3 square roots of 7. Then we're going to do our inner terms. Our inner term is going to be plus 3 square roots of 7. So let's look. Our inner terms is this, the square root of 7 in that 3. So 3 times the square root of 7. And then the last in this situation is the square root of 7 times minus square root of 7, which is going to give us minus the square root of 7 squared. So let's continue and simplify this. I'm going to leave that 2 out there. I'm going to say 2 times 3 minus the square root of 7 all over 9. Let's look at this. I have minus 3 square roots of 7 and a plus 3 square roots of 7. Those two terms will cancel one another out. And then lastly, minus the square root of 7 squared. Well, that's simply going to become minus 7. So our answer becomes 2 times 3 minus the square root of 7 all over 2. And our final step for this particular example would be to go ahead and simplify or cancel out our 2 here. And our final answer is just going to become 3 minus the square root of 7. And that is rationalizing the denominator. Now let's look at a couple of problems that I want you to try. Or before we do that, let's think about this really quickly. Let's look at the situation where we multiplied by the conjugate. Let's think about something that happens when we do that. So I'm going to erase this and we're going to look at some properties and why we choose the conjugate and some neat things. And it'll be a nice little shortcut that we can use the next time we actually want to multiply by a conjugate. Instead of having to FOIL out the entire problem, we'll learn a quick little shortcut. But if all else fails, we can always FOIL because we know that we can get the final and correct answer. But let's learn a little shortcut method. So really quickly, let's think about this. What happens, what's the property when I multiply conjugates? So let's look at it. Let's look at something really easy. Let's look at if I have x minus the square root of 2. What's the conjugate of x minus the square root of 2? Well, the conjugate of this guy would be x plus the square root of 2. All right, so let's look and see what happens when we multiply or FOIL this out. So once again, what happens is first term, once again, you get x squared. our outer terms. That's my outer term. My outer term there, we get plus x square roots of 2. My inner term becomes minus x square roots of 2. And then the last term becomes minus the square root of 2, that quantity squared. Okay, well let's go ahead and simplify this example or this problem once again. So once again, we notice what happened was that our middle term canceled out there. And we were left with x squared minus the square root of 2 squared, which ends up being 2. So the beauty of this, of multiplying by conjugates, is that when I do this, you end up with the first term squared. So that's my first term squared minus the second term squared. So once again, it's the first term squared minus the second term squared. So what am I saying? Let's look at that once again. It's my first term, which my first term is an x. So x, that quantity squared, minus my second term was the square root of 2. And we said it's just going to be that quantity squared. So once again, if I look at that, that would give me x squared minus 2, which is exactly what we got right there. So this is a shortcut way. Once again, it would be the first term squared. Notice that's my first term, x. Raise that to the power of 2. The term in the middle will always, the sign in the middle will always be minus the second term. My second term is the square root of x. And I raise that to the second power as well. And that's simplified simply to x squared minus 2. So that's a nice, quick little short method. And we'll look at one last example of this. And I think you guys will have the hang of it and be able to work on these problems on your own. So let's look at this and get some more going. Let's get this one last example. And I'll change this one last example up just a hair, and I think you guys will be ready to tackle this. So my last example is, what if I want to rationalize the denominator, and I have 3 divided by the square root of 5 minus the square root of 4. Let's look at that. So once again, what's different about this? In this particular problem, I actually have 2 different square roots, but that's okay. We notice that we have a plus or a minus there, so we know that we have to use the strategy by multiplying by conjugates in this situation here as well. So what is the conjugate of the square root of 5 minus the square root of 4? Well, that's simply the square root of 5 plus the square root of 4. So once again, remember, the conjugate is the exact same terms, opposite sign. So I need to remember the numerator and the denominator. So I need to put that up top as well, plus the square root of 4. Now we have to just do our simple algebra by multiplying across. And when we multiply across, we end up with 3 times the square root of 5 plus the square root of 4. All over. Now let's use our quick strategy here. Remember, because they're conjugates and we're multiplying conjugates here, we can end up with the first thing squared minus the second thing squared. So what does that look like in this situation? My first thing squared, or my first term squared, is the square root of 5. So I'm going to write that. Square root of 5. And remember, I said squared. Minus. Now that's very important. That sign is always minus in this case when dealing with multiplying conjugates. And then the second thing squared. Our second term is the square root of 4. So I'm going to write the square root of 4 squared. So that's our short method instead of foiling it out. In this particular case, let's look at what we have. 3 times the square root of 5 plus the square root of 4 all over the square root of 5 squared. Well, that nicely gives us 5 minus the square root of 4 squared. Well, that gives us 4. So in this particular case, when I continue this particular problem, what do we have? We have 3 times the square root of 5 plus the square root of 4 all over, well, 5 minus 4 is simply 1. So my final answer reduces simply to 3 times the square root of 5 plus the square root of 4. And that is the final answer for this example. So thank you very much. We went through and used our shortcut method in this last example. Thank you and have a great day.